Hello everybody, welcome back to Electric Vision Entertainment. I am your host Aleia. Here we talk about tech, thoughts, thick hair. We have fun playing with electronics, we build robots, we learn coding, we do all sorts of things in this platform. Just pure science, technology, having fun with each other. If it's your first time here, thank you for joining. Like I said, we do all sorts of things related to technology. We talk about science, we build different circuits, we learn how to design schematics, we just generally build stuff, have fun. And if it's not your first time here, welcome back. Thanks for subscribing so that you got the notification that we were going live. We do go live the same time every single Saturday at 2 p.m. Pacific. So you can always find us here on Twitch, YouTube, Facebook. If you didn't get an alert, I guess it means you need to subscribe so you can find out about the other shows. Because we are, for those who've been here, you know, it's been a cycle. We've been growing along as time has passed, we've evolved. So as we continue to go on this journey, we're going to continue to evolve. We're going to do more robotics, heavy type things, which also leads to us doing more coding, doing more hardware, doing more electronics. So it all blends in, you know. As a programmer, you do have that tendency to just want to code things, and that's great. I mean, I personally, that's why I went and studied data science, is so that I could get more knowledge about like coding and how to build like AI and machine learning things and put it into my robots. But I knew that it wasn't just that one thing for me. It was using this coding to help make my machines better as well. So that's just a tip for anybody who's thinking of like going to school for coding, or who's studying it outside, or just interested in it in general. It doesn't have to be just the one thing that you focus on. You can blend it all together. I think that's the world we live in. Everything's blended together. It's like a tech renaissance in a sense. But so just to go over a little bit of what we did last week. We worked on some more circuitry. So the past few weeks we've just been kind of doing different circuits, trying things out, seeing how we can make the code interact with the circuits that we're doing, as well as just having fun doing small little projects. And then I said before, as we move forward, you know, we've learned how to do coding, do schematics, do soldering. So now we're trying to use all of those skills to build more advanced machinery, more cool looking robots, and just make fun stuff. But in order for that to happen, we have to go over, you know, the basics of how to use the language we're using, which is, it's Arduino. It's based off C, but they just call it Arduino. So if you know C, C++, super easy to transition to. If you don't, we'll work on it. We'll practice. That's what we're here for, right? And so we worked on that. So we're going to be doing a bit of coding. I'm not going to do so much schematic, these heavy things today. Today, we're going to focus more on, we're doing like music and melodies. So we interacted with a buzzer a little bit before, a couple episodes ago. We're just going over like, these are the basic components that we have, right? This week, we're actually going to utilize it. So we're going to set up a piano, we'll say, because we're not going to put like 128 keys on there or whatever. We're going to use 4. I might throw a few extra on, seeing how we feel. But we're going to see how we can code different buttons and buzzers so that we can, you know, make a melody just by pushing buttons if we want to. As well as setting up a sequence to say, if I give you set amount of notes, this is what I want you to play for me in return. So that's what we're going to do today. So with that being said, I'm going to go ahead and share my screen so you can see my workspace and kind of where we're going to get started. Yeah. So I'll set up there. So if you've been here before for other shows, you'll recognize this layout here. I'll go over it real quick for those who may be new. But it's pretty, you know, we've worked with this circuit before a few times where we have our power and our ground, the red and black line. On the board is a blue line, like over here, but usually the standard is red is for your voltage and the black line is for your ground. So then we have 4 buttons set up. They're all set up the same way. So on our power line, we have it going to our button. So yeah, our power line is going to our button, and then it's going to go through a resistor and back to ground. So that's that full circle that we were talking about before. And alongside, on the ground side, I'm pretty sure you can put it on the ground side or the power side, but usually safer to put things on the ground side. You're less likely to burn out components. But we have a line that's going to be our signal, and it's going to go to our board. So that's basically, without this signal, technically stuff is happening. The button is functioning, it can work. But without the signal line, we can't tell it what to do. So they're all set up to signals here. And then back here, and so we touched on it just a little bit before, but because of the sound of the buzzer, I was like, we're not going to mess with this because they can get to some high frequencies and be really loud. So at the time, like, let's just go over all these other components. We'll come back to this another day. Today is that day. So here we have the buzzer with a positive and negative side. Let me take it off so you can see. There's just 2 pins on the bottom. Just 2. One side is positive, one's negative. It tells you which side. Kind of glance there. It has a little plus on it. These are called like piezo, P-I-E-Z-O buzzers. Pretty small, pretty simple. There's bigger buzzers. I've done this project or a similar project to this in the past where, I don't know if any of you remember because speakers have gotten so much more advanced now. There's those like computer speakers we used to have like a decade ago. And running out the back was just a red and a black wire. That's all it was to it. So in this scenario, I could take one of those and just strip off the back wire, like cut it, strip it off, put the red on the power, put the black on the ground, and then connect, this is our signal for our buzzer. So I can connect this to the ground side, and then that way I can tell, rather playing this through a little buzzer, I can have it set up to play through a whole speaker. So you can use different things for that. These ones are just high pitched. I didn't have another speaker. I would have done it with another speaker. So, and then of course we have our Arduino. Most likely this will be our standard flow we work with on the show because it's just simple, straightforward, intuitive. As I mentioned before, there will be a show probably in the next few weeks in which we build an Arduino on here. You can kind of see the layout pretty similar already. Not all the way. But there's a simple layout. The most important thing is the pins on the side where you can plug things in, as well as making sure this chip in the center on the Arduino, this guy, because it's surface mounted, we talked about it a little bit on the other show about different types of soldering. Because this one's surface mounted, it's smaller, which is the purpose of having things surface mounted, so it's tiny. Versus on this one, we will use a whole chip, which is why this center is laid out the way it is. Having chips laying around. So many parts. Our circuit, our integrated circuit is going to look more like this one because we're surface mounting it. So these pins along the side, they're plugged in. So I'm going to take it out. It is stuck in there. I think I showed this before. This circuit. And yeah, so this is our integrated circuit. It's similar to the one that's on here. The only difference is it's set up to be through hole. So I can set it up on that board, just slide it into place, solder it on, and then it's done. If it was surface mounted, it would still be the same piece, just extremely smaller. And like I said, we'll see if we're going to do any surface mounted things on this show, just because it's so intense. It's intense. As well as the fact that just magnification, honestly, if anything. Usually when you're surface mounting, you have to like have the magnifying glass right over because it's such tiny parts. We'll see. Make no promises. But if there's a great enough interest, you guys let me know in the comments, or like go on the Discord, or message me on Instagram, or whatever the case is. Like, hey, I'm really interested in surface mounted soldering. Let me know. And we'll see. I'll try to put something together for everybody. So, hello. We're gonna go ahead and plug this up. I'm not gonna power it. I'm gonna disconnect the serial port from my computer because I did test this on the show. Well, not on the show. I tested this before the show, just to save us a bit of time, because sometimes building these out can take a little bit of time, and just general layout of starter code, quote unquote. So it is technically programmed in here. So I'm just going to connect it, but I'm not going to power it up. Like I mentioned before on the show, I'm a very big fan of not powering things until I know it's set up properly, because I don't. There's definitely been moments where I've burnt out components. Even this buzzer here, I think almost burnt out. I don't know if it's the exact same one. I have a broken one sitting like right here. The back fell off. I don't really want to try to reconnect it. Yeah, it's like the little component broke. And I probably would have to solder back onto the back of that buzzer. And I don't think it's worth it, to be honest. Buzzers are expensive. Most of these little parts are pretty inexpensive, except when you start getting into bigger things with solder, actual microchip, things like that. But otherwise, like a resistor, like 2 cents or something like that. So it can be a transition to get these components, but I think there's a lot of starter kits out there if you want to do this yourself at home. There's a lot of intro starter kits. I know one of the ones I got wasn't too expensive, so it's kind of easy. Of course, if you want to go into more depth things, more advanced parts, then you have to go from there. But just to start off, maybe I'll find one and like recommend it out to everybody on the next show. Send it in the chat. So off the top of my head, I know where these are going to go, so I'm going to plug them up, and then I'll show you the code so you can understand why I put them, where I put them, kind of the start of how I set this up, and then we can play around with some stuff after that. So these are my 4. I think we have 7, 8, 9, and 10 is my buttons. So let me just go ahead on here and plug up all of these. So 7, 8, 9, and 10. And then I believe one of those are 6. I got that. So we got all these bad boys in there. And then we have power and ground. So I'll plug those in as well. I could technically have set this up to where this signal is on the other side of the resistor and plugged in, and it would power it through the pin. But just for like resistance sake, power sake, design readability, we're just gonna do it this way. It makes more sense to see how the power is moving throughout the system. So I'm gonna put this power to 5 volts. That one. Yeah, that one. All right, so now we have this all set up. It said it's disconnected over here so that I can run and like screeches our ears out. And then go ahead and show you this one. This is my starter code for this. It's all over the place, but it works, and we're gonna play around with it and do some things. So the main difference in this one than in the other ones is that we're starting off. You don't have to use this exact line, and I'll explain what this is. But when you do computer science, you'll notice, or you'll learn, that it makes more sense to kind of compartmentalize it, break things down into chunks. So I can have one file that solely does this one thing, this other file that does one thing. It's like organizing your notebooks or stuff like that. And then I could say, well, rather than having one long file that's like 2,000 lines of code, I have 5 that are like 600 or so. 400 lines of code, 600. And so it increases the readability, it keeps things clean, it helps with like runtime. So for our purposes, Arduino has a library set up. They have a bunch of files. Like if you go to the sketchbook examples. There's a bunch of examples that they give people for how to work like basic components, just try out different things, get you really like started out with things like that. So for this one is pitches.h, and this .h means header. Basically, it's not going to do anything. It's like a dictionary. It's like a reference sheet. It's like, I'm gonna go ahead and set up everything over here, and then that way I don't have all of this extra in my other code that's actually doing something. I can run one file, it'll go look at the other file for me, bring it back, and do it that way. So basically what this file does is for this buzzer, just like, if you're into music, I'm not really super into making music anymore, we'll say. I used to play piano a lot. But for our purposes, for building a piano, if, each key has a different note, a different sound, different frequency, etc. So in this case, we're defining those. So I want to play the G1, right? I think they'll set up directly to actual key names. I forget what the association is according to our Arduino's header file. But it what it does is it just says, okay, this note is going to be at this frequency. This note is at this frequency, and sets it up. And then that way, when we come over here, later when we use it, I don't have to say, oh, set up this variable to be this number, or this to be this. It's already defined, it's constant, is there. You'll see down here when I'm setting a note, I don't have to put the exact frequency. I can just say, play this note. And then it'll look back at that file, find the variable, get the number of the frequency, bring it back, and run it. Just what that does. So it's very useful in these cases. I know, which one did I do? I think I did a walking robot. I think it was for that one, when I did a walking robot. And I set up a lot of this logic in terms of, if it runs into this, do this, or these are all the settings for how the servo needs to be set up, or where these locations are in a different file. And that way, when I came to the main one, just like, go. So up here, we did similar to what we did with the Larson scanner, for what we did for the simple Simon game that we made last week. Go ahead and set up all of the switch bits. So the switch pins are buttons. We're saying there's 4 of them. And as I put on the Arduino, 7, 8, 9, 10, right? And then we have our buzzer, which we set to 6. And the reason we're setting it up here rather than using the actual numbers in the code is for consistency's sake, for readability, and just so that we don't have any errors later with logic. We can fully understand what's happening all the time without trying to decode where numbers are, what they mean later. We're going to skip this for the moment, because for now we just want to get the basic setup running, see that it works, and then we can try a little more, like making a song or something later. We're just going to play random notes probably. So here, of course, we have our setup. As I mentioned before with Arduino, it has to have a setup and a loop. This just defines everything that's necessary. It's the basic, like, what are you? Before you can do something, you have to say what something is. Before I can tell the tree to grow, I have to be like, you have bark, you have leaves, you drink water. This is our setup. So we set our buzzer as an output here. And then similar to the other ones, we're going to have a for loop. So we don't have to put 4 of these lines saying pin mode 7 is an input, pin mode 8 is an input, 9, 10, to however many we decided to add on. If we made a whole piano, we would have extreme amounts of code to put in here to say these are all our different buttons that all mean different things. So you just put a for loop and it'll take care of that for you. And then in here, our void loop is the second half of our Arduino code where we need to say, this is what I now need you to do. And because it's a loop, it's going to keep doing it forever. Just want to unplug the power, because as soon as I do it, the thing about Arduino is different from running regular code. So when you run regular code, it runs and then it's done, right? It's not really putting it anywhere. It's just do it. And then it's the end of the day for the most part. When it comes to programming Arduinos, embedded systems, integrated circuits, FPGAs, which is a different type of electronic circuit. It's like a Arduino, but extremely more. They're the type of things you find in your everything, actually. When it comes to doing things like that, you're not only running the code on your computer, you're sending it to the chip. So now, let's say, somewhere, that chip that I held up before, even the main chip on your Arduino, those instructions have been written to it and they're going to stay there until you tell it otherwise. So that's the thing about machines that makes it a little easier to work with. It can be useful, it can be not useful. But that's the whole point, is you build something that once you unplug it from where you have the main power source or the dock, in our case, our laptop or our computer, to code it, it can still run. So that's how we have these independent systems like cell phones and laptops and lamps and video cameras. Is we've built it in such a way to where the instructions are written on that circuit, which is like his brain basically, and now it knows what to do from going on. So that's what we're doing. So once I turn it on, it's just gonna keep going. Let's see. I'm not gonna do this one at the moment. This just buzzes it. Might as well. I'll plug it in and just buzz it real quick. Hopefully it's not. Well, I think you'll be able to hear it. It should be fine. It was pretty loud. It's super loud. And Arduino never wants to allow me shortcuts to uncommon things. So I'm going to plug up our buzzer. It shouldn't be. We'll upload this. And what's going to happen? So we're setting our tone, which is the built-in function to control buzzers. Arduino has a lot of built-in functions for controlling a lot of things, so it does make it helpful, especially when it comes to motors, servos, really more intense input-output systems like that. They have their own built-in functionality. I'm sure there's ways to do it behind the scenes. I just stick to those built-in. If it's built-in and it's going to do it for me, that's great. As a coder, you hit a certain point where like everything does not need to be made from scratch, because we'll be here literally all day, every day trying to do that. So utilize your resources. So in this function, it takes 2 to 3 arguments, and the arguments are just things you pass in to tell it what to do. So I'm saying tone, basically buzzer. Then we set up what is the pin. So for our case, like buzzer, we only have 1. And we set that up before with the buzzer 6. So it knows pin 6 is going to be our buzzer. The next argument here is the frequency that we're going to send to it. I'm going to send the same note actually for our purposes. This is set up. And the thing about this, if you're familiar with computer science, is basically, I'm going to do that one. Like using the library. You don't have to say what it is every time. Once you've kind of imported it and say read from that file, you can just utilize that constant from the file for however long. So we're going to say pin 6, play this note. There is a third argument you can set up, which is duration, which is why I had this durations up here for different lengths of notes, so like quarter, the eighth, blah. And so if I said like 500, it'll play for like 500 milliseconds. So we're going to do that. Then of course we have our delay, which is 1 second. So first we're going to get milliseconds. And then no tone, just be quiet. Basically, turn the tone off, don't make any sound. Same thing, we set it up as whichever pin we wanted to do, and then stop it again. So the goal is to play a sound, stop for a second, and just stay stopped. I don't really need the no tone. Well, I guess I do need the no tone, or it's gonna keep buzzing. So not the tone that's turned off. So I'm gonna do that. Let's see if you can hear it. Hopefully that's audible. I'm assuming it's audible. But I would switch, but there's really nothing for you to see over here because of sound. But if you can hear the beeping noise, that's what it's doing is Playing for 500 milliseconds, turn off the again. So we're going to try a different note. I don't know. C5. Down here. I'm going to put in C5 and upload it. And it will just change the sound. Yes. Okay, cool. I'm not going to play all the sounds for very long just because I know the audio does not like them. This is difficult to do for a music show. We'll make it work. Yeah, we'll just try to pick like a really cheap one, see if it comes through halfway decent. If not, we'll just, play them and let's not keep them going so that you don't blow people's ears out. That is not the goal of this. So I'm just holding my finger over this for everybody so that no one can hear, no one's ears gets blown away. But it's kind of hard to tell, but definitely the tone of it is changing. That's what we're just looking at this. I'm not going to demonstrate too many. Instead, I think it's pretty straightforward. It's different frequencies, different sound. Yeah, so I'm gonna unplug this so don't do too much. But this is the basic gist of this. It's the important thing to know is just this function is how you control it. So it's going to be, of course, those 3 arguments. And as I mentioned before, Arduino has tons of resources online to tell you how to use it. It's like when we did, I forget the site at the top of my head. There's arduino.cc/reference, which is similar to when we did P5.js. And they're both based in C. There's a potential we might do something like that in the future. Because the reason I actually found out about processing.py and P5.js and like all of these were because of wanting to do visuals, but they're based off of the C language. So you can, P5.js is JavaScript. But either way, you can still integrate it pretty easily with Arduinos to where you can set up a screen and tell it, read from processing and run this and paint this picture. So there's lots of different ways to integrate stuff like that. But I think just like we did P5.js and they had like a really well documented sheet saying like, here are all our functions, here's use cases, here's example code, here's what it does and doesn't do. Arduino has that set up as well. So I definitely will go to their reference page and look at their notes about tones, for speakers. I said, because we're using this specific speaker, the Tinsel buzzing speaker, this one, it automatically is just high pitched. Like, you can only do so much. So in the future, if we do something like this, I'll probably get more bass heavy things if we do any more musical things. Personally, may or may not. Music is nice. I enjoy it. I'm not one to make it. So we'll see. But if so, I'll get like an old school like speaker from like 95 or something. That definitely is not high pitched. And we can still do the same thing with it. So let me take this off and comment that out. So now we know it works. It's the important thing. Let's go ahead and uncomment this and talk about what it does. So to make a piano, it's not just about having the sound work, because then it's not really a piano. It's more just like you playing music through a speaker, a very small, very high-pitched speaker, but it's a speaker nonetheless. But in order for it to be a piano, you have to have buttons, and you have to have it where touching those buttons or pressing those buttons generates a certain sound, right? So what we are going to do, we have all our buttons set up, everything's connected to our Arduino. Now we just have to tie in and set up that if statement where if I push a button, make this sound. So we're here. There's, again, a more efficient way to do what I'm going to do for the rest of this show, but we're practicing. We just want it to work. That's One of the biggest things you'll probably learn in computer science is there's like the brute force way, and then there's like the more like readable, nice, efficient way. For our purposes, we most of the time on the show brute force because unless I already have it written out to make it very cohesive, sometimes translating things from brute force to efficiency is very time consuming and intense, and we want to make sure it can work. So for us, this would be like our MVP, our minimum viable product. What is the very least thing we can do to get this to work? If you know me as a roboticist, as an engineer, as a programmer, I'm very much a brute force type person where like, look, it works. Okay. We can worry about making it clean later after we know it works. But for now, let's just get it functioning. So our main if statement or needs for us is to set up all our keys. This will be for every single key we have. It's going to have the same logic where if we read a signal as high, right? Digital read that's saying either look at an input or give out an output. So digital read is look at the input, digital write is give an output. And then we pass in 7 as our parameter. So we're going to say button number 7 or button at pin 7. We'll go to the keyboard and do that in a moment. Equals, of course, this is our logic-based equals. So we're not saying set it to high. We're just saying like read if it already is. Is this true or not? Is it high? Is it on? Pressed? If so, then we're going to set our tone on button 6, our buzzer, which is pin 6. I don't know why I have 6 here. Let me just say a buzzer. That's the whole point of that. And then we're not going to worry about duration because we're just pressing it. We want it to just go when it's pressed. And then we'll set our notes. I'll use the same note from here. Instead, I'm not going to hold it too long. We're messing with this ear. So we're working on the sound. Last few shows, we worked on the video quality. Today, for the next few weeks, is sound quality. So definitely hit me with feedback on that in terms of if it's too high pitched, you can't hear things, do hear things, there's background noise. Definitely hit me up and let me know so I can work on fixing up for you guys. So we have our tone. We're going to delay it by 10. Don't really need to technically, but because of the issue I mentioned before with bouncing, where sometimes it'll the metal arm or brace in there that's making the connection when we push it down. You know, it's very thin. It's like aluminum foil. You shake it and it vibrates a little. So it's the same thing in there where once you push it, sometimes it'll just barely move a little and it'll read as high again, even though it should be up. And it should technically be reading low. So you add in a delay just to be like, within 10 milliseconds, whatever wiggle bouncing that's going on in there should be done. So we shouldn't have any issues for whatever our next conditional is, or this was a while loop, it doesn't go back in there before something else happens. All sorts of trial and error with that. And then if it's not high, so if you haven't pushed it, then don't do it. Turn it off. And the reason I put this here, we tested it out a little earlier. If I just had the statement, then when I push high, the button makes a noise. And then if I decompress and I let go, it's never going to turn off because I already told it, well, now we've read that it's high, turn it on and just leave it there. So you have to say, if not, if the button's low, if I let go of the button, then no tone. Of course, different scenarios. For a piano, that's how they work. You know, push the button, it plays, you let go, it's done. You may have systems though where you're kind of like with the LED, it's like I push it once and it stays on. This could be something like that, where like an alarm system. I push it once and it keeps going. And then you say, well, in this case, if I let, you know, maybe I go put my hand in front of the scanner, then it turns off. So cross in front of the ultrasonic sensor we were playing with before, pick up a signal that's close, then turn it off. Maybe we'll make an alarm system since I know people seem to be interested in that. So I'm gonna plug this in, I'm gonna muffle it. Don't do too much noise. I'm going to upload this, it should work. Cool. Right, and I'm gonna share so you can see the button for here. And first we have our 4 buttons. This was 10, so this is 7. And I'm just going to push it, and you should hear noise. It works. So I said, if I hadn't put that if statement in, then as soon as I pushed this button, it would have played the sound, but it would have just kept going. So now we have it set up to where it's just button presses, right? So that's the basis for our piano. I don't have a spreadsheet of every single note on the piano. It's been several years since I played one. I don't remember all of them in order. So what we're gonna do, we're just gonna play around a little. I'm gonna go ahead and just set up the other 3 buttons to just random noises, random tones, and we'll see what we get. We just push some buttons to see what it sounds. Then after that, if we have time, maybe we can set up a melody. Whereas I have this for loop. Not for loop. I have a list of a bunch of different tones, and I say play all of them, and then I'll just play them in sequence, and you should just get a song out of it. I'm pretty sure how I originally did that. We'll switch this back so you can see what we do to edit the code, and then we'll play the piano. So I'm gonna just hold if statement. Maximum comment, because apparently I do never comment my code. People are like, you should do that. I guess I know. I'm working on it. So this one is 4 times. And I said you could probably do this with a for loop. Yeah, you definitely do this with a for loop. We're gonna, for ease sake, do it without. Probably wouldn't be too hard to set up, but because of time, I'm trying to get everything, try to get it all in at once. For that. So set all the common stuff, and it was button is which 7, 8, 9, 10. I associate it by pins or button numbers because I don't show like they're labeled. If I had a schematic, I probably would put like 1, 2, 3, 4 or left to right or whatever the actual pitch of it is. But in this case, because we have them set up to pins, we are going to associate them by that. So in pin 7, we'll keep at the same note. Pin 8, we are going to put this note. Pin 9, we're just kind of random. Hopefully the sound is distinguishable enough to be heard without being screechy, super screechy. We'll see what we put that in as this one. Okay, so now the different notes in. The only other thing we have to do is change our buttons. So we have button 7, 7. Button 8 needs to be pin 8. Button 9 needs to be pin 9. And 10 is at 10. And then the buzzer stays the same, so we have 1. Because they're all in separate if statements, none of them should work. None of them should overlap. So it's like if I push 2, if I push 2, we'll find out. It might. Want to see what happens. Another way to do this is we'll switch cases. Meaning, I will find a way to bring it up in another show. We're not going to go too much into how that works at the moment. But it's basically like a cohesion, a list of options. Think of it like, you call a company and you're like, press 1 for operator, press 2 for billing, press 3 for customer service. I don't know, technical stuff. That's basically what a switch case is. I can say, start up here. If your read is a 2, then do this. If it's 3, then do this. And it doesn't set them up as a bunch of separate if-else statements. It's just one long, if you read this, here are your options. So that's one way to set it up. I'll figure out a way to do that in the future. It will do something with like that ultrasonic sensors, like if the distance is this much, do this option, turn left or turn right. Yeah, we might do something like that. Just coming up with this. Also, I'm gonna upload this. think everything looks good. It says everything is good. Let's switch screens and see if everything is good. So, see if you can get 4 different sounds out of this. It said hopefully it's distinguishable. Not, you'll at least hear a sound, so we know it's worse, even if the pitch is odd. So down. So the other different pitches, I don't think this was asking for this, but we got a little deeper sound here, deeper there, high pitch, deeper. So if I were to, you know, in this landscape, as I mentioned before on the show, this is for prototyping. Like your breadboard is there to just make sure your code works, basically, and that you have the general idea of how the schematic should be set up and if it works here. And then going forward, we're not going to do it today because I didn't think about it, to be completely honest. Should have been a moment for us to do more soldering and put it on here. But let's see if we can do that on another show where we build it out on the board and then we transfer it completely into the proto board. But you set it up here, you transfer it to your proto board, lay it out exactly how you want and make sure it looks on here as well without the breadboard's layout underneath. It just gives you a better sense of how the wiring is going to be when you actually design the schematic. It is not already designed. And if you wanted to get it to this point, how you need to set up the wiring for how it's going to just be laid out, where the components are going to go, things like that. And that way you're a little more solidified in the idea of how big does this need to be, how much space actually, where are these traces going to go on our board. What am I making? So this is, in the simplest of forms, a piano. And so we're not going to build a full piano today because wiring and things like that. But it's the general idea that we're able to get a buzzer and a few buttons, and we can push the different buttons and just play the melodies. So that's basically what we're doing on the show today, is trying to set this up. And in the future, what you could do is get something like this. Say I put, like, transfer this on here and put a whole bunch more buttons on it. I could put, say, I don't know, 4, 10, 8, let's say 8. Maybe I could put 8 buttons on this side, 8 buttons on this side, and then I could literally play like this, but it will work. And just put, like, you know, battery up here, the buzzer, put the buzzer up here, put the battery down here with, yeah, well, the battery. So, yeah, connect the battery at the bottom, buzzer at the top, buttons on the side, and then just, I could literally independently play this and just put the battery attached, and I have, like, my own electronic harmonica. Maybe we'll continue that another week where we, rather than just transferring it over to here, for example's sake, we actually fully build out. If I can get, I have a battery count, but I'm pretty sure this is enough. Most of these circuits usually don't require that much power, it's like 5 volts. So a 9-volt battery is usually the default that people go to when they're doing Arduino-based projects, unless they know for certain that they have, like, relays or motors or servos, things that require more power. But in the general sense, 9 volts is, like, putting enough. So you can do that, and that's what we'll do, and we'll go ahead and completely build it out onto here. Maybe that's what we'll do next week. They'll transfer this onto here. We'll solder in the battery, we'll solder in the buzzer, and we'll make a little harmonic. We could do that. That'd be our way of going from starting at something like this to going from something like this and transferring it all the way on here. So say if I disconnected the Arduino, I can still make this work. These are programmed onto there. So this one we are. So I'm going to share my coding screen. I'm going to try one more thing. Double check my reference. Select this one. So I'm going to come up here to the right. Uncomment this. All right. So what we're going to do. I'm not going to use the buttons for this, and we'll comment out a lot of that. But for right now, we're going to say we have a melody, right? Say I wanted to just play a whole song. I didn't want it to be associated with any buttons or anything like that. I just want you to play it. Then I'm going to tell it, this is my melody. Here are the notes that I want you to play, right? And it's an array, basic list of things in it. So I'm going to put some notes in here real quick. So I'm going to take those same ones for the most part and throw them in there. Play 4 notes. I'm not going to worry about the duration again. We'll see. Actually, no, we might do a duration real quick. We got a little bit of time. It shouldn't take too long to set this up, hopefully. So I'll take these notes. Just going to play these 4. And part of me is like play Jingle Bells, but I don't. At one point, I had all the like notes which memorized. I do not anymore. So we're just gonna roll with this. Do it. Let me put 4 notes in here. Listen, in this case, it's set up to where 4 is a quarter note, 8 is 8th note. It's just a list of how long we want this to play. And then that should stay the same. We're gonna come in here. We're gonna do all of this gone because we want to play the melody. I'm not going to do it with like button start. Like if I push the button, play this melody. If I push this, play a different melody. Which kind of like how you do ringtones, and things like that. If it's this person, play this melody. If it's this person, play this melody. For our purposes, we don't need that because we're doing hardware. So what I'm going to do is set up a quick for loop. This is how I set up like half of my code. Let me know if this is confusing or if you have any questions. Yes, let me know if you have any questions about this. I know I'm kind of rushing through it a little bit, just so that we can try to get this working before we end today. Okay. Cool. So I'm gonna keep the same setup from 0 to 4 just because our melody has 4 notes and our note durations also have 4 notes, pins, so just keep that. So what I wanted to do is gonna go through this loop. Tone at that point, still connected. Instead of saying this note, I'm gonna tell it to play melody. I'm going to play that, whatever tone is at that point. So the first time through is going to be 0, then 1, 2, 3. And then for our duration, we're going to say all duration. Notes. Durations. That's not how you spell notes. Note durations. Yeah. Just unplay it, stop for a second. We'll go 500. And then 500. Pretty sure that should work. Pretty sure. But to find out. So the basic sentence is going to go through the first time, play a note for, in this case, a quarter note. Then going to wait, hop 50, 500 milliseconds, turn it off, wait 500 milliseconds, play a different note. So we're going to see if this works. You shouldn't have to push any buttons because I'm not interacting with them. I'm just like buzzer, turn on this melody, turn off this one. Hopefully it's distinguishable enough to be heard and it's not going to be too like cray. So this, so we'll see if this works. And I am, let's see, is it in here? I'm missing the semicolon, guys. So that's what it is. Where is it? Double check over here. Just close the numbers and use semicolon and what I'm talking about. I can get this situated on time. Don't in the chat if you know where I'm missing it. That's the processing. I definitely don't see it. And then this way. Yeah, so just putting in these numbers. Oh, there. I'm pretty sure that's what it is. Pretty sure. Let's see. Yeah. So picky. This is why, I'm be honest, this is why I stick to Python, because it'll not only will this error messages be a little more like cohesive, but I was like, I'm pretty sure it's a syntax thing, either as a colon, a semicolon, or colon brace missing somewhere. Doing it without this comma, it doesn't understand what's going on. It's like, is this a string or these numbers? If they're numbers, why is there space? So a comma would be nice for it. So let's try this one more time. So verified it, which just sees if it works without actually uploading it. So that's why I just stopped trying to upload it. Uploading verifies it and then uploads it. But in that case, I was like, I might as well just like get it functioning real quick. So upload it. Let's see if you can hear it. I don't know if you can hear it. I mean, which microphone is my microphone? So I don't think that's too high pitch, I'm assuming, but it's like kind of hearable. I'm gonna do this again. I'm going to change these durations to like, I don't know. I'm just going to put 20s and 10s because why not? And then that way with a longer duration, it's not just like a little click click noise. I'm trying to show us what it is. So what we're hearing. So you put 9. No, it's right. It's 8. So we have 8 different notes. Then you don't worry about this. And then we'll put that readability. And then we're just going to read the sequence over twice. So let's see if this works. Okay. Let's try that. So I'm not gonna play it too long because I know it's like probably super high pitched still. But hopefully I leave it connected. You can hear that there's different pitches happening. The duration makes it a little easier to hear because it's longer. So I'm gonna plug it so I don't get too much noise interference. But that's kind of how you would set that up. Say if you wanted to, like I said, even make like a doorbell, whereas you have your circuit set up behind like a case, and you program it to say, if a button is pushed, then play this whole sequence. So even for this, and then I can put, if button 7 is high, then put this for loop inside it and say, rather than just turn it on, wait, whatever, I can put this whole chunk in there and say, if I push this button, play this whole song for me. Same way, so that's one way to do these things. I think those are the main things we're going to go over today, partially because time, partially because I think that covers all of it. And it's back to the camera. So it's kind of just showing that even on just a basic circuit like this, we've probably built like 3 or 4 different things with more or less the same circuit, right? We work with just turning an LED on and off and how we can do that with or without a button. We just learned how to work buttons in general. We've made with this similar-ish setup with the LEDs instead of buttons, where we can have a Larson scanner going back and forth with buttons and LEDs, making a switchboard where I can hit the buttons and the lights go on and off. And then, or memory game, which was the same, with a lot more logic, a few other little things. And then today, with using the buzzer, not only just to make different sounds that you can hit with it, but also how to integrate different buttons and make a piano. I could add it if I had a really long and more in-depth board, so we would need a lot more pins or some sort of relay device or something like that, a hat for our sensors. We put a lot more buttons on here and we built a fully functioning keyboard where now, I don't have to go buy one. I can just make one at home, which we do all the time. We surprisingly cheap on the internet. And then as well as making your own music on here. There's different coding languages out there that teach you how to, I know there's one called like Rockstar where you can code in a language that sounds like rock music and it'll translate it into like lyrics or tones and sounds. This is kind of like that, but with hardware, where I can say, here's a song I made up. I don't know, I might be bored one day and just get a bunch of those pitches and just throw them in all over the place, change the duration, and just see what music I get out of there. So who knows? Maybe that'll be like a theme one day. I'll just sit here, like, I'm gonna come up with a theme music for this show, but I'm gonna code it all with this and record it, which sounds like a lot of work. But we'll see. Let's see if there's any questions in here for not too much. Okay, so that being said, this is our music, quote unquote, music episode. And then we went over how to make our own music, whether by making a keyboard and doing like hardware button presses on different keys, quote unquote, or we can make our own music by coding in the exact tones that we want. Yeah, like I mentioned before, I could go online and find like a music sheet that lists out, oh, this is a E flat or a C sharp or whichever, and just get the associated pitch from that pitch sheet and just put it in place and say, hey, it's at this point, at this tone, line it up accordingly, and I can play a whole song. Consider doing that today, but as I don't remember off the top of my head, and I didn't get a pre-made sheet for us to have everything situated. We'll see in the future. We'll make some interesting stuff. So that being said, again, if you have any questions for me, definitely reach out to me on Instagram, my Discord, well, not my Discord, the Make School Discord, which is make.sc/join Discord. Make sure you subscribe to the Twitch so that you can get us every week. There's my show on Saturday. There's Yusuf's show on Tuesday. There's workshop. There's Brian's show right after mine. There's interviews. There's coding sessions. There's all sorts of things that we do on the channel. My show is just one little piece of it, but hopefully you enjoyed it enough to want to subscribe and come back next week. We do it every Saturday at the same time. Different, same old me, different old show. And then we've been doing new shows. Earlier we did a coding pancake show So we have some weird shows, but they're pretty fun. It's nice to just like, you know, there's the more technical side of coding where it's like, yes, I'm coding things and building software and building websites and systems. On the other side, like, it's just a fun way to have fun, you know, playing around with different things, seeing what's possible, what's not possible, what you can make out of these tools that you have. So that being said, this is everything else we wanted. I'm going to end our show for today. Thank you again for joining me. I will see you all next week. Hope you enjoy your weekend, and definitely make sure to see you next time. Bye.